So one of the things another way of thinking about that is if you've ever seen like a bed sore. I know this is rough. It's like, well, how do you go to bed sore?
I was like, yeah, why would we go there?
I know. I know. Or areas of a human's body that aren't healing. Yeah. It's because the immune system is over recruiting itself in that specific area. And it keeps making immune cells that keep eating the collagen when it's trying to make it. So your body's making collagen and your body's eating it faster than you can make it. So it starts making it bigger and bigger whole. Does that make sense?
Yes.
So you can do that to your muscles. Well, you can do that to a lot of cells in your body. In fact, if your body gets too hot, this is why I'm going to groundbreaking concept here. That's why heat stress, like actual heat, hot yoga, sauna, okay, is only good if your body can balance oxidative stress. Training applies heat. Well, guess what? If I'm already super emotionally stressed, I'm making a lot of heat in my body. So now I go work out and make more heat, and then I go to hot yoga to calm myself down, and I create more heat. Yeah. It's no wonder you're a swollen, puffy mess the next day. Yeah. And then wondering why you look fatter from the experience. However, at first, it will always work well. Right? So, ooh, I did this for 6 weeks and it did great. Why would it not work for 6 years? Right? So what I'm trying to give people a sense of is in something very simple like overtraining and then you're super swollen is a perfect example of balance between oxidative stress and antioxidant balance. And if anything disturbs that balance, your performance goes away. Brain fog goes up, digestive issues ensue, right? Swelling, and poor return from your physical stimulus in the gym. That's the same thing that goes awry in what? Autoimmune disorders, Hashimoto's, people that seem to be like having a hard time losing weight, menopause, same symptoms, right? And then we start blaming other things. Like we start going, well, the thyroid's a little low. It must be called hypothyroidism. Or there's a cyst on her ovary. It must be PCOS. Or, she's maybe just, not training hard enough. So we train them harder and they get more swollen. So we say it's not enough caloric restriction. It's not enough eat less, move more. Well, we try to give it a name to describe what we're seeing, and this criminal is very tricky because this criminal leaves a trail of evidence that would put you on the path of another person. That's hypothyroidism. That's menopause.
You said PCOS.
Yeah, right? Yeah. It'll do that. And then you'll get confused because the only thing that you've done is name the comorbidity, but not the root morbidity. So very similar, gentlemen. If we were still in a time where we are at with immunological research related to the human health, is we are at the same place when 60 years ago, we didn't know that there was something called metabolic syndrome. Right, and so we thought that high blood pressure was the root cause of high blood pressure. We thought that hyperglycemia was the root cause of hyperglycemia. We thought that morbid like obesity and all of those things. Well, do you know 1 in 2 people have high blood pressure now?
Yeah.
1 in 2 people. And do you know that everyone gets diagnosed for that because there's a pill for it? People get diagnosed for pre-diabetes. There's a pill for it. People get diagnosed for high cholesterol because there's a pill for it. People get diagnosed with obesity because there's drugs for it. But no one gets diagnosed. 85% of those people have metabolic syndrome and only 35% of them are diagnosed. Well, why the hell is that? Because there's no pill for metabolic syndrome.
Yeah, it's working all of the systems too.
Right. So what is metabolic syndrome? Metabolic syndrome is essentially a level of inflammation that is built in the vascular system that has gotten so high, it now triggers secondary morbidities upon which we give diagnoses. So you're springing leaks.
That's a way of saying it.
Yeah, you're springing leaks, right? But that's not the root.
Do you think that hyperinflammation then first causes insulin resistance and then the rest trickle on down. That's what I would think.
That's ROS and inflammation buildup. ROS is a silent killer we're not talking enough about, and it will become the main thing. That's what we're really talking about with like NAD, methylene blue. A lot of these things, we're really discussing the oxidative, like redox process, like oxidative stress. And in a weird relationship with it, we need it to survive because it leads to antioxidant production and cellular function. We produce it as a waste byproduct of producing ATP. And it does really cool health benefits. Like if you had no radical oxygen species, your bodies would deteriorate because it leads to regeneration. So we need it. And actually, we need to induce it. That's why like a little bit of poison is a good thing. Every food in the natural known world has a carcinogen in it. And it leads to an oxidative stress that leads to regeneration. It leads to pro-hormone response and oxidative and antioxidant release. Your body from oxidative stress releases like antioxidants and produces more glutathione.
It's always like your body testing itself against steel.
It's the perfect balancer to a crazy world. It knows this. And so I want to make sure that people have context to what we're saying. So let me give you a very simple example. Everyone knows, and that's why if you've ever get in front of a CICO warrior that's all about caloric intake, and it is about that. I don't want to say it's not a important part. The law of thermodynamics must always be true. Let's be clear. I don't want to say that it's not. But do not tell me that after they say that, go, well, then what about menopause, Mr. Smarty Pants? Please explain to me why someone can lose weight at 1,200 calories, go through menopause, and now can't lose weight, almost starving herself. And yes, it's true that there must be a certain calorie level that we can get that person to, that if we starve them long enough, but that's not helpful, right? You're just trying to win an argument. You're not trying to help people. That's the problem with research warriors, in my opinion. They're just trying to win arguments. They're not trying to be useful. If you're trying to be useful, you'd come up with answers that explain what we see in reality to what we're seeing in the research, but you don't want to have that conversation. So menopause is an immunological upregulated state. Menopause is like pre-autoimmune disease because you got all the symptoms. They're constantly swollen. They're constantly brain fogged, on and off gut issues, endocrine functions acting funny, right? On and off hair shedding, never get the cold or flu, right? So you'll notice there's some truths to this. So what I started noticing is that my weight loss resistant clients, their biofeedback looked just like my autoimmune clients, looked just like my chronic EBV cases, looked like my chronic Lyme cases, anyone that had chronic C anything behind it. When I did their histories, and we're talking, again, I've seen 55,000 cases because I've reviewed so many. And that's not even when I worked with the doctors. You want to took all the time I worked with the doctors, I've seen over 90 to 100,000 cases. So I don't think that there's anybody that has better clinical review volume than me. And so I've been able to put these histories together. And then I started noticing similar patterns in their blood sugars. And I started noticing similar patterns in their inability to lose weight. And then I noticed all the similarities in their histories, like their symptom history. And I'm like, no, because again, I'm not a genius of research. I am great at pattern recognition. So I see patterns and then I reverse engineer it, right? I'm not discovering it new by like doing research. I'm putting big data sets together, seeing patterns, and then isolating a sample size and reverse engineering. That's what I do. And that's why we figure things out that no one else does, and then we try to teach to everybody. But what I noticed is that people that were having like menopausal women, their sugars will react like a pre-diabetic, but it's the same as the sugars of someone who's now got the cold or flu, which was weird. So if you ever look at someone's sugars when they have the cold or flu, they're doing crazy stuff.
Down all around.
Right? Yeah. And it's like, that's really weird. Why would that be happening when they're rested? Right? Why would that be happening? It also happens, just so you guys know, at ovulation. It also happens at menstruation. And it's because the immune system, by the way, is integral to fertility. It's what helps the follicular stimulating hormone and the follicle and the egg to drop. When you learn about how much the immune system actually is what's in control of fertility, you're going to really put something together when you go from 2020 and then you look at the rates of infertility. You're going to understand it. Well, the immune system is the most taxing pro-inflammatory thing in your body. It requires so much energy to run an immune system at a high level. Huge energy demand. So and it likes sugar because it has to run on quick energy. It can't wait for you to sit around and burn a 9-molecule fat cell. It needs instant. So it needs glucose. So there's a whole field of biology. So any of you that don't believe me, immunometabolism. It is a field of biology that will teach you about quiescent inactive immune cells versus active cells and what they run on. And so, interestingly enough, when a cell gets damaged, a mitochondria, it's less and less able to burn fat and it can only run on sugar. If you get too many cells that are running on sugar together, it leads to ROS being unresolved. ROS being unresolved draws in lymphocytes. Lymphocytes are your adaptive immune system. It's the learned immune system because it's like, hey, what's going on over here?